Okay, let's do an example and find all the points of inflection for the function 2x minus 1 to the power of 4. Remember that points of inflection are the points where the concavity of function changes. Okay, so let's do concavity is always related to the second derivative, so let's do find f double prime. So f of x here is 2x minus 1 to the power of 4. Then f prime of x, we need to do the chain plus power rule, so 4 times 2x minus 1 prime, 2x minus 1, 1 less power. So this is 4 times 2 is 8, 2x minus 1 to the power 3. And then from there, f double prime of x is, well, 8 times 3 times 2x minus 1 prime, 2x minus 1 to the power 3 minus 1. And that gives us, well, that's 8 times 6 here, is 48, 2x minus 1 to the power 2. That's step one, but we know that points of inflection happens at points where f double prime is equal to 0 or f double prime is not defined. So find points at which f double prime is not defined or it is defined and it is equal to 0. Here, the second derivative is a polynomial, so f double prime is defined everywhere. We are not going to have any point at which f double prime is not defined. So we need to look for points of this form. So f double prime x equal to 0 means that 48 times 2x minus 1 to the power 2 is equal to 0. That means that 2x minus 1 squared is 0. That means that 2x sorry, 2x minus 1 is 0, and then x is equal to 1 over 2. So that's the only possible point that at which the concavity may change. Then step 3, we have to be careful. We have to check if the concavity changes at that point or not. So check whether or not the concavity, which is equivalent to sine of f double prime, changes at 1 over 2. Okay, so we need what? We need the sine table here for f double prime. We know that at half it is 0, and then I have to find the other values. So let's just pick test values. Here I can put 0, here I can put 1, and f double prime at 0 is 48 times 2 times 0 minus 1 squared. This is 48. 2 times 0 is 0 minus 1 squared. That's just 48, which is a positive number. Since at the test value it is positive, it will be positive for all values of x from this interval. F double prime is going to be positive, and for f double prime at 1 we have 48 times 2 times 1 minus 1 squared. This is 48 times 1 squared, which is again 48, and it's a positive number. So f double prime is going to be positive here. Now you can see that the sign of f double prime didn't change. In other words, the concavity of f is always upward, and it's not changing when we pass the point 1 over 2. So as a result, we can say that f has no points of inflection. And this is an example shows that not necessarily all the points which make f double prime 0 are inflection points.